Hi guys, so welcome to yet another video tutorial on NumPy arrays, and today we are going to be talking about NumPy standard data types. Now the question is, what is NumPy's standard data type? So let's start up with this. Right now, NumPy arrays contain single values of a single type. So let's just maintain that. So they contain single values of a single data type. Right now, it is important to understand why the knowledge of these data types, because they have limitations, and some of the reasons they have these limitations could be memory concerns, right? So here what we're going to talk about is we're going to look at some of this, why it is important to specify data types in NumPy. So here the question is, why specify data types in NumPy. Data types in NumPy. So, of course, there are reasons for that. One of the first is memory efficiency. It's really important. With memory efficiency, different data types require different memory amounts or different amounts of memory. And by specifying the data type, you control how much memory your array uses. So memory efficiency is 1. 2, performance optimization, right? So it is important, again, performance optimization. Right, NumPy is designed for high performance numerical computation. So when you specify data types, that allows NumPy to optimize operations, knowing exactly the kind of data type the data is working with. So the third is precision control. So here we go, precision control. Make this. Right, now when dealing with floating point numbers, specifying the data type lets you control the precision of your calculation, right? Because there's definitely going to be a difference between a float 32 and a float 64, because the float 32 uses less memory. So depending on the problem, you should, think about that. That should be something you should be looking out for. Then finally, we should be looking at compatibility and consistency. So here it is, compatibility and consistency. And so the question is, what is this, right? Now, when you specify data types, you have to ensure your arrays behave consistently across different platforms, right? So this consistency is vital when you're doing data analysis and all. So these are the 4 things to look out for. So, but for us to talk about that, let's just write some code, and so that let's get to understand what all this is all about. Now, the first thing I'm going to do is we're going to simulate a year's worth of temperature readings. So let's do that now. So here we simulate a year's worth of temperature readings. So yep, temperature readings. Now the temperature readings is going to be second by second reading, right? So that's what it is. Now to put this in perspective, it's saying, look, we have 65 days, 24 hours, 60 minutes, and 60 seconds. So that's what we're going to do. So here, to put it in perspective, we're going to say num_readings, right? And then we say 365 days times 24 hours times 60 minutes times 60 seconds, right? So we have that. Now, Now what we're doing is we're pretending like we have sensor data, right? So what I'm going to do is I'm going to put this typically like a sensor data, and then make it do like a pseudo random generator that tells us this is a uniform distribution. So here, this is what I'm going to do. And to do that, I'll now use float 32 to save memory, right? So this is where we're going to do that. So I'm going to call this sensor underscore data, just to put the intuition going, right? Then in here, we're going to say np dot random dot uniform. And this is what we have here. If I use shift and tab, it tells us there's a uniform distribution from low to high. You can see 0.0 to 1.1. And we're going to draw samples from a uniform distribution, right? And samples are uniformly distributed over a half open interval, low and high. So that's what we're going to do, because we're going to simulate this like a temperature reading, and we're going to, use number reading as context, right? So now I open this, and so for the low, because we notice this, you can see we have low, it's part of the parameters. We're going to say, since it's temperature reading, we're going to say the low will be equal to, say, minus 10.0. Then the high is going to be equal to 40.0. Now, here we are now going to introduce a parameter size. Now, because it's important, if you look over here, there's supposed to be a size that you're going to put in the parameter here. And this is also a way for you to understand that you can use the parameters in a NumPy method, because they have NumPy methods and functions. Now, so the parameter we'll be using will be, you guessed it right, number underscore readings. So that's what we'll be using here. I'm trying to use the tab button. Okay. No, there's a mistake. Yes, I ought to have said size, right? And then equals to num underscore readings. And then that is closed up. Now to save for memory, we now put as type. We put as type. So this is just going to convert it, and we say mp dot float 32. Right, so you see, that's what happens here. So with this, right, we now have sensor data, right? And with sensor data, we can now run this. With the sensor data, we'll run this. And now look at what we're going to do. We're going to print, and I'll open bracket. I use an F string, and I'll say, what is the data type here? And here, when we say data type, we're going to say in here, sensor. No, there's a mistake here, right? Sensor data dot d type. So that's the initial sensor data dot d type. Then close it with a curly brace, and then finish it up here. Then next, I'm going to put a print. Then put an F string here. Then I'll write memory used. And with memory used, we're going to look at sensor data. And with sensor data, we want to find out the memory used. So we call this n bytes. Now the n bytes we're going to have is going to be divided by typically 1024, right, multiplied by 2. And then we are also going to use a dot, this notation here, 2f, because we are trying to understand what it is. in terms of memory, and we'll put 2 MB here. I will put MB here, then we'll close this, and then with this we have this closed, and then we typically have that. Now here's what we're going to look at. So when we run this, ooh, what's wrong? Do we have an error somewhere? Yes, we have an error. Dot data type. Lovely. Now you can now see the data type is float 32. The memory used is 87.34 MB for this. Now, so the thing we need to understand here is this. We created the NumPy reading to simulate like a year's worth of temperature data. And then we went on to create a uniform distribution that just looks typically like this. So this is a whole lot. If we were to check out, if we were to print num_readings, look at what we have here. That's massive, right? And then if we're now to get the temperature reading and we look at sensor data, you know, we have all this set up. And of course, if we look at size, you know, we have all this set up, and you see this is the size. To reduce the temperature to optimize, we now use a floating point number, because a floating point number seems, you know, it is 32-bit floating point number, and the data type would balance the memory usage and the precision needed for the temperature reading. So yep, so this is the whole idea of NumPy standard data type. So I just had to show why it's important, you know, to, you know, write out the data type, to specify a data type when you're using NumPy. You don't do that, it's just going to use a default one, right? So again, watch the video, understand the intuition, and we keep moving forward, learning NumPy data, standard data types, and NumPy arrays, one object at a time.